Alright, in this video we are looking at how to convert coordinates from polar to rectangular and from rectangular coordinates to polar coordinates. So here's your two directions you're going to go. Polar to rectangular. Remember xy is rectangular and polar is the radius and theta. Or from an xy coordinate you're going to convert it to a radius theta coordinate. Alright, so there are some conversion equations that we use. Alright, to find x, you take r, the radius, times the cosine of theta, which should make sense because cosine is the horizontal component. To find y, you take the radius times the sine. Remember, that's the vertical component. And that's all you would do to find the xy coordinate. If it's in rectangular form, to find polar, okay, the first thing I would do to find theta, I would use the tangent. Remember, tangent is the y divided by the x. And in order to find the theta, you would use inverse tangent of y over x, and that will tell you what theta is. Then for the radius, remember this equation? Radius is going to always equal x squared plus y squared. Right? That's a circle, if you will, because everything is a circle in polar coordinates, right? With a center of 0, 0. So to find the radius, you take the x value, square it, add it to the y value squared, and that's your r. And then, oh, don't forget to take the square root, because that's going to give you r squared, but you only want r. I hope that makes sense. So you might think of r as square root of x squared plus y squared. However you want to think of it, it's fine. Alright, so let's try some of this. Polar to rectangular. Okay, so if it's polar, I need to use the equations x equals r cosine theta and y equals r sine of theta. Right? So, to get my x-coordinate, I'm going to take the radius, which is 2, times the cosine of pi. Y is going to be 2 sine of pi. Alright, think about your unit circle. Well, x is 2 times, what's the cosine at pi? Think about your, here's pi, right? What's the cosine over here? That's negative 1. What's the sine over here? Well, the sine is 0. So this is negative 2, and this is 0. So my coordinate pair is negative 2, comma 0. That's my answer. Try example 2. Using the same equations, x is equal to the radius times the cosine of pi over 6. Y is equal to the radius times the sine of pi over 6. So again, use your unit circle, and let's think about this. Square root of 3 times unit circle. What is the cosine of pi over 6? Well, look at that. Pi over 6 is down close to the x-axis, and the cosine there is square root of 3 over 2. Okay? So if I multiply these together, square root of 3 times square root of 3 is 3 over 2. That's my x. For the y-coordinate, I get the square root of 3 times, well, what's the y at pi over 6? Well, that's 1/2. So when I multiply straight across, I get the square root of 3 over 2. So my coordinate pair then is 3/2 and square root of 3 over 2. I want you to use the unit circle. I don't want you to use the calculator and move them into decimals. I want you to use unit circle and fractional answers. Okay? Now let's try some the other way, rectangular to polar. So remember, for rectangular to polar, to get theta, I would do the inverse tangent of y over x. And for r, you use the good old circle equation. So r would be the square root of x squared plus y squared. Alright, so using these two, I can solve. So for theta, I'm going to do the inverse tangent of y over x. So where's the tangent negative 1? Think about your quadrants, think about your tangents. Where's the tangent negative 1? Well, you have a problem here. It could be 3 pi over 4, or it could be 7 pi over 4. How do you know? Well, go back to the point here. What quadrant is this point in? If x is negative and y is positive, that's quadrant 2. What angle is in quadrant 2? 3 pi over 4. So this cannot be my angle. Okay, go back to your point to determine what quadrant. Now, to find the radius, it's going to be the x squared plus the y squared. It's going to be the square root of 1 plus 1, which is the square root of 2. So my polar coordinate would be the square root of 2, comma, 3 pi over 4. All right, let's try another one. Example 4. All right, before we go any further, let's think about this. Where's this one? Well, at 0, 2. So this is right on the y-axis. So keep that in mind as we go along. So theta then is inverse tangent of 2 over 0. Well, that's undefined, right? Y over the x. Where's the x 0? Well, look at your graph. We already decided it's here. What angle is that? That angle is pi over 2. So for the radius, 0 squared plus 2 squared, well, that's the square root of 4. So my coordinate pair is the radius first, comma, the angle, theta. So 2 pi over 2. So some key points to remember when you're doing this: figure out what quadrant the point is in, and that will help you determine the angle. It's real important that you do that. So I want you to try these. Okay, I want you to try one to convert to polar from a rectangular, and one that you convert to rectangular from a polar. We'll go over these in class, but I want you to attempt them on your own. All right, use those unit circles and what you already know. Good luck. See you in class.